cheap way to make a pre-screen for your Amarine. 2-liter bottles, 2 of them. Cut off one at the shoulder so it just fits over the Amarine pump. And it goes up to there. It'll hold it right there, creating a kind of a backbone. And then you can put these nut milk bags. They're $9.99 on Amazon, but you get 3 of them. For that, it's just a pre-screen. It's not going to be perfect. And then put this one on the bottom. We're going to use these 5-micron carbon block filters. You have to flush for 10 minutes. This is the 5-micron. This is a 1-micron. We're going to follow it with a 0.2 micron. But I put in this little rig to flush out the filter without having to take apart the whole filter system. But you can see there's a bunch of carbon fines coming out of there. Definitely don't want to clog your downstream filter with those carbon fines.
Whenever you have any electrical device that employs a coil, turning it on and off can create voltage spikes which can be damaging. One problem with solar powering pumps is that when the solar power gets too low, the pump can turn off. When it goes back up again, it turns on, and this excessive on and off cycling can cause pump failure. With some careful planning of your circuit, however, you can minimize the chance of this happening.
So here's the basic schematic of the circuit. We've got our PV panels connected over here, our battery connected over here. One of the distinct advantages of using the load output on your controller is that you can have a low voltage disconnect already built in. Many of these controllers, like the Renogy, have an automatic off. When the battery gets down to 11 volts or 22 volts for a 24 volt system, it'll automatically disconnect. And when it gets back up to 12.6 volts or 25.2 volts for a 24 volt system, it'll automatically turn the load back on again. So that's a way that you can prevent your batteries from being damaged and prevent your pump from cycling. It's built right into many of these controllers, but if it's not, you can actually get a device for $10 on Amazon that'll do the same thing. For example, this one.
This is set to disconnect when the battery reaches the low point of 20 volts, but then it will turn back on when it goes 4 volts higher. In other words, at 24 volts, when the panels start charging in the morning, it will go back on.
But in order to use the load port on your controller with these pumps, you have to use what's called an NTC, or negative temperature coefficient, inrush current limiter.
That is not necessary if you're running off the battery, but if you're trying to run off of one of these, they don't like super high currents. They'll turn off as a safety measure. So all that does is slows down the current at the very beginning, but then it goes down to very low resistance once the system is running. It's called an NTC, inrush current limiter.
And we have to the load port, the NTC current inrush limiter is in series. I just put it in series with the negative terminal. You could do it with the positive terminal as well. This is all connected through the fused distribution block, but then we just have the all in parallel, positive going to the pump, negative going to the pump, but also the positive and negative going to this freewheeling diode. Notice it's connected the wrong way for current to flow through it. This is positive, this is negative over here. Current wants to go that way, but it can't. What happens is when the pump is turned off, it allows the current from the pump to continue through there, so the voltage spike can be absorbed by the motor.
We've got right here a Schottky diode that will handle the back EMF when the pump gets turned off.
So hopefully some of these ideas helped. If you have further questions, feel free to drop on by and ask a turtle.